Welcome to Study Loop.
So for this problem, there are two directions involved, west and east. So let's take the west to be positive x, and obviously east will then be negative x. Now, the for solving both the parts of the problem, we will need the same equations, and only the variables of those values, only the values of the variables will be different. So first, let's derive all the equations that we are gonna need, and then we will just plug in all the values in place of the variables and solve for the two parts. So we know that uh, velocity v square is equal to u square plus 2as by kinematics, where v is the final velocity, u is the initial velocity, a is the acceleration, and s is the displacement. Now, for to solve this problem, there are two ways. Uh, One is the work energy theorem, and the second one is using kinematics. Here, I'm going to use kinematics in order to solve this problem because I think that this method is relatively uh, shorter than the work energy theorem method. So, yeah. Now, this is the equation that I wrote down using the kinematics. Now, since we are already given the electric field, we can find the acceleration by using this equation. Now, once we have acceleration, we can substitute this over here in the first equation, and rest of the values to the variables are already given for both the parts. So after that, we can plug those variables and solve for v, which will be our answer to both the parts. Now, in the first part, we have to solve for the velocity of the electron. Now, since, as I said, our convention is such that west is in the positive x direction and east is towards the negative x direction. So, going with that convention, our initial velocity will be equal to negative 4.5 times 10 to the power 5 meter per second. S is the displacement is in the east, so it will be negative, just like the initial velocity, and that is equal to 0.375 meter, negative 0.375 meter. And the electric field is towards west, so this should be positive and has a value 1.5 Newton per Coulomb. So now the first thing to do will be to find the acceleration. So let me just write this to be equation 1 and this to be equation 2. Now for an electron, charge is equal to 1.6 times 10 to the power minus 19 coulombs, and mass of an electron is 9.1 times 10 to the power minus 31 kg. Now using these three variables, we can find A using equation 2, and this comes out to be equal to, so let me plug the values, 1.6 times 10 to the power minus, instead of doing this way, we can first express velocity in terms of these variables by plugging this expression of acceleration over here. So that way we will just have one equation to solve for. Okay. So now by just solving this equation, we can find velocity since we have already expressed our accelerations over here. So doing so along with all the directions, take them into account. we find v squared to be 400, 403. This is going to be a long value, 0.197802 meter per second square. Therefore, v will be equal to square root of this value, and hence that will be equal to 632694.395 meter per second. It's better to express this in terms of kilometer per second, so we can have a relatively short value, small value, so 6.32 approximately kilometer per second. So this is the velocity of the electron in the first part. Now in this part, we will follow the same equations, and over here the initial velocity is negative 1.9 times 10 to the power 4 meter per second. Make sure you consider the direction so that this will be minus or plus accordingly. S is negative 0.375 meter because this points towards east as well, and charge on the electron is 1.6 times 10 to the power minus 19 coulombs. Okay, so this is actually negative, so make sure you you use negative sign over here. Yeah, that's the only correction, I forgot to wrote that, but the values are the same, the calculations are uh, correct. Now proton has a positive charge, so this is the value. Then mass of the proton is 1.673 times 10 to the power minus 27 kg, and anything else. And electric field is the same, that is positive 1.5 Newton per coulomb. Now again we will use this equation, the box one, where we have the acceleration expressed in terms of the known variables, and solving for this equation we find v square to be equal to 253408846.3837, and therefore, so this is square of meter per second, therefore v will be square root of that, and this comes out to be equal to 15918.82 meter per second, and approximately this is equal to 1.15.918 kilometer per second. And over here, I guess I made a mistake. So dividing it by 1000 will give us 632.694 kilometer per second. And similarly, this is 15.918 kilometer per second. So this is the velocity for the final velocity of the proton, and that's part B. Thank you.